Previously, we moved into the foundation last week. In order to carry out foundation work, you need to know what your site is about. So you need to carry out site analysis to review the documents that you can find either on the internet, from a consultant, from authority, or from experience from various parties, including the contractor. You can pick out images from satellite, from Google Map, visit the site, locate where are the access, what you can see on site, what is available, what is not available. Do your analysis, where you're going to bring your material from, where your machinery will be parked, and plan for further investigation, including the soil investigation. The 3 steps, including the desktop study, where you get the document, review them, analyze them, to your site visit, the site reconnaissance, physically visiting the site, feel the site, do initial tests, take photograph, take video, record with your checklists, observe, do your initial survey, establish the level, establish the corner peg, the boundary. Buy services plan from utility company, like a power cable, water cable, sewer, water pipe, telecom cables, and do your cable detection, detect where they are. Do trial trend to expose them. Engage the utility company to recognize them, to make sure that you are looking at the right services. Some may not be clear enough, therefore you may need to call a few. And then you plan your soil investigation. Then where you want to do your borehole, how deep you want to bore the hole, what type of test you want to carry out, whether in situ or lab. And then you verify those with your designer. Once you've done all these preliminary works, your design then can come out. You can then proceed with your actual work, including site clearance, if there's any existing structure that you need to demolish, any tree that you need to remove, build any temporary site office, site toilet, site rest area, site canteen, divert any utility if necessary. Do your setting up. Where are your building? What is the grid line? What is the level that you can build to? Do your site layout. Access is very important, especially for your equipment movement, your material movement, and your site will change through time. From day 1, it will look empty. Day 2, month 2, year 1, year 2, it will change as you build up. Access will change. So you need to plan ahead. And update your site layout every few months, or when there is a big change in your site layout. Site office is something that you must plan way ahead. There's a lot of money to spend. For a site office of this site, if you look at this picture, if it is a 2-story site office like this, two blocks of these, one opposite each other, will cost in the range of $1.2 million to build. It's not cheap. You also need to plan utility, the power, the water, sewer, telecom, and other utilities necessary to equip your site office for the use of the staff. Hey, if you need to call, get out. Are you listening to me? Out. If you're receiving a call, taking a call, out. I cannot tolerate these in the class. Do remember this. You need to buy furniture, tables and chairs, air conditioning unit, computer to equip, that you can operate it as your site office. Security. Make sure you have securitized your site, hoarding, fence, locks, CCTV, detection. Make sure that your site is secure. There's no unauthorized entry, because in the law, if you allow unauthorized entry, that person or their equipment get damaged or injured, it's your responsibility. Material. When you have material, expensive material that gets easily stolen, like cables, make sure you have security to look out for them. Storage, you must have sufficient storage space, proper laydown area, proper access to it. There's no point having a space where you put material you can't get to. You need to have access that links to it so that you can bring your machine, your lorry, in the front to it and from it. Welfare and sanitary facility. Welfare is very important, especially for workers, because you are using the workers to work for you. You must provide them with sufficient rest area, sufficient water, sufficient sanitation, so that they can maintain their productivity. Equipment and plant, you must plan what type of equipment that you need. Crane, what size, what type, where is it going to come from, where is it going to park. Every services we talked about earlier on, for your site operation, water, power, sewer, telecom. Those are the 4 main required services. And now you can plan for your excavation. Excavation for your basement, excavation for your underground installation. Excavation can be done using open cut if we have the space for it, because open cuts require space, because you're going to slope your soil. You need much larger space than your actual building. As long as you can afford that space, you may consider open cut. You also need space for your soil storage, because later on you need to backfill those areas, avoid that you do not have structure in. Or you can do excavation with retaining system. Retaining system can be sheet pile, CBP, contiguous bore pile, secant bore pile, or even diaphragm wall. Open cut, as the name goes, you cut to open to the sky. You excavate with your excavation open to the sky. Open cut is the simplest, the easiest, the cheapest, but it's subject to weather. Weather in Singapore, a lot of rain, especially year-end, monsoon season. If you do your open cut during the month of November, December, you will face a lot of water from the sky. You end up with a lot of pumping and you can't progress much. So avoid deep excavation during those months if you can. Or you do other provision, have very big pump ready to pump water, or you can have shelter or divert the water somewhere else. Sheet pile for structured excavation or as a retaining system is the cheapest, easiest, but is not strong as compared to diamond wall, CBP or SPP. But it's easy. If you have shallow excavation, stiff soil up to SPT 40, you can use this method. Easily install with hammer or vibrate hammer. Once it's installed, it can be retracted for reuse when you finish your work. Sometimes you need strutting, like you see in the picture, horizontal steel member to strut it, or you can leave it as cantilever. Advantages and disadvantages using sheet pile: lightweight, reusable, high resistance to driving. You can drive the steel material very hard. Long shelf life, can last quite long as long as you protect it properly. You can extend the sheet pile simply by welding or cutting if you want to reduce it. However, it has disadvantages. Sheet pile, you can't use it as a permanent structure. Cause noise and vibration. If you're in a sensitive neighborhood, you may need to think of other options. Difficult to install when you have soil with boulders or hard structure, and you make sure you interlock it, otherwise you have water ingress problem. Diaphragm wall, compare sheet pile to diaphragm wall is 10, sheet pile is only 2 in terms of strength, but in terms of cost, diaphragm wall is most expensive, but the strongest. Operation to install diaphragm wall requires you to build the guide walls. The guide wall will give you the alignment of the diaphragm wall. Diaphragm wall needs to be excavated using machine, either is grab, not the taxi, but the grab machine to remove the soil, or hydrophase or cutter to remove rock when you encounter it. You need to cast the diaphragm wall in panels. In Singapore, panel size typically is 2.8 meter long. One panel is 2.8 meter. That is a standard size. You need stop end to demarcate where is the panel joint. Advantage: suitable in soft soil, very strong, very stiff. Can be used as permanent structure. You can build diaphragm wall and use it as your permanent wall. Use it as your foundation. Very stiff, therefore it induces very minimal settlement to nearby building. If you use diaphragm wall and you do a top-down, your construction time or duration could be less than other conventional construction method. It's better in waterproofing property, watertight, because of the joint between the panel. However, not economical to use shallow foundation. Diaphragm wall is good for deep excavation, like more than 15 meters excavation, and in sensitive area, for example, next to a MRT tunnel, MRT station, all buildings that are sensitive, and it needs special equipment. You need the cutter, you need the grab, you need the descender, you need a lot of big equipment to carry out diaphragm wall construction. CBP is in between diaphragm wall and sheet pile. If your soil is competent enough, you don't have too deep excavation up to 10 meters, you can do contiguous wall pile or even secant wall pile. Cheaper than diaphragm wall, but more expensive than sheet pile wall. Uses the same equipment as bolt pile. So if you have bolt pile and want to use the similar equipment on site, you can consider CP, contiguous wall pile. That's how it looks. Contiguous wall pile have a space between the wall pile of about 100 mm. And always, for wall pile wall, you need the capping beam to cap them together so that the wall or the piles can act as one. Second low pile, you have overlapping this time rather than gaps between them, creating the soft pile, we cut into it by the hard pile, making a continuous ball pile wall. SPP, second ball pile wall, has better waterproofing, water tightness property than CPP, continuous ball pile, but less water tightness than diamond. Then we talk about excavation method for your basement construction. You can do excavation to construct your basement using a bottom-up sequence where you excavate all the way down and build up from there. Or you do a top-down. Where you build the level 1 slab first, then you excavate below that level 1 slab for your basement structure. At the same time, you build upward simultaneously. If you compare the two systems from the surface, you will feel bottom up takes a longer time because you have to excavate all the way down before you can build. So there's a constraint, you can't do anything else but excavation until the bottom first. Compared to top down, you can build your level 1 slab, you can do your excavation underneath, build your basement, at the same time you build your level 1, level 2 and so on. But there's a catch because in top down construction, once you build your level 1 slab, your excavation underneath that level 1 slab becomes more difficult because you have something over your head already. You are excavating underneath it. So that excavation becomes more difficult and it has more restriction because you're working in a confined space. Your access is limited, the ventilation is limited. You then need special equipment, small excavator to move the soil around to the opening. You need a telescopic excavator to remove them, or crane and bucket style. However, that gets compensated by the capability of building upwards simultaneously. Two things you need to remember and understand: in top-down construction, you must have permanent retaining system like diaphragm wall, SPP, in order to do a top-down method. If you use ship hull cannot be permanent, therefore you cannot use ship hull for your top-down. Reason is, when you cast your level 1 slab, you are connecting into your permanent structure. They will take the load. And at the same time, you must install something called king post. King post to act as a temporary column to support your above superstructure, at the same time your downward excavation slab. You must have additional king post to act as temporary column as compared to bottom-up construction. Bottom-up, you do not need any of these. You only need to excavate down and build upward. That's the two comparison, two methods. They have both advantages and disadvantages. While you're doing excavation, deep excavation for your basement construction, because you are removing soil, creating a void inside your excavation, whether it's bottom up or top down, you are creating a void, and your soil outside of your drainage system trying to press into your excavation because you are creating a void. You are attracting the soil into your excavation, therefore you will induce a lot of soil movement. Soil movement that needs to be monitored. You want to know how much the soil has moved. If you do not monitor it, you do not know how much it has moved. Reason we want to monitor your soil movement because there could be sensitive structure nearby, MRT tunnel, MRT station, power station, bridges, tall building, sensitive building like very old building, for example. Power cable that is next to your excavation. Those are the items that you need to make sure you do not cause damage to them. Therefore, you want to know how much your soil has moved caused by your excavation. In order to do that, you must install instrument. Instrument will then tell you how much those soil movement has been caused by your excavation. Instrumentation then is to be installed at the right location to monitor the right movement. Inclinometer is one type of instrument that you can install into the soil to monitor lateral movement, lateral soil movement. There are two types of inclinometer. If you install it in soil, it's called in-soil inclinometer. You can also install that in your diaphragm wall, SPP, CPP, and those are called in-wall inclinometer. IS, in-soil inclinometer, or IW, in-wall inclinometer. Both monitor lateral movement. If you install it in soil, you monitor the soil lateral movement. But if you install it in wall, then you monitor the wall lateral movement. Piezometer is another instrument that's installed in the soil to monitor the piezometric pressure at that level. Why you want to know the piezometric pressure in the soil? Because when you cut the soil out, you will also cut below the groundwater table. Groundwater table also wants to be attracted into your void. Therefore, you may reduce the pore water pressure inside the soil, outside of your excavation. What does it mean by you reduce the pore water pressure? Reduction in pore water pressure indicates consolidation. Consolidation indicates settlement. Earlier on, inclinometer for lateral movement, piezometer for vertical movement, settlement. You want to know how much water pressure has been reduced. Water standpipe, quite similar to piezometer, but water standpipe is a physical pipe that you can see water inside. You install water standpipe in the ground to allow the groundwater table to sit into the water standpipe, stabilize. Then you can measure the water level inside the water standpipe. That is a physical detection of groundwater table in water standpipe. Of course, the water table is in soil, and you want to check your reading from water standpipe with your piezometer to check these two are reading the same value, same trend. If your water standpipe indicates there is a reduction of 500 mm water table dropped 5.5 mm, then you must also verify your piezometer that there is a reduction of piezometric pressure by 500 mm or in the same range. If they have conflicting data, then you need to review what caused that difference. Ground sediment marker, very straightforward. You place them on the ground, in soil or on the surface of the road to monitor the sediment. Ground improvement is the next item. Why do you need to do ground improvement? Why do you improve the ground? What is the purpose of improving the ground? Why you do ground improvement? Because your ground is soft, not competent to take the load, not enough capacity. Therefore, you must improve it so that it becomes stronger, more rigid to take the load. Ground improvement is necessary in certain type of construction, certain type of ground. Ground improvement when you have very thick layer of soft soil. Very thick layer of soft soil that you cannot remove. You must live with it, but it hinders your operation. It gives you too much sediment. Therefore, you must improve it so that it reduces the quantum of the sediment when you load onto it. To support your building, you can design piles. You can bring the load down, further down. But when you have the building sitting on soft soil, you can't avoid sediment. That's where you need to improve the ground. Improve the soil underneath it so that it does not cause too much sediment. Ground improvement can be done with various methods. One of them is the surface compaction. I'm sure you've seen big roller that roll on the soil to compact it, or you have seen those little ones that workers push up and down, or the one that jumps around. We call it dancing lady. Those are surface compaction, compacting up to 500 mm of soil, causing the soil to be more packed. Remove the air from the void, making the particle more compact, giving you a harder surface so that you can lay your road on, put your slab on, you can cast your ground level slab on that surface. Ground improvement can be done also through grouting. Grouting is a process by inserting a pipe into the ground and you pressurize with water, cement, or mixture of those so that you can mix cement and soil together to form a column. We call those jet grouting process. You can do micropile. Micropile is a type of non-displacement pile, but smaller in diameter, up to 500 mm. Anything more than 500 mm diameter will be a ball pile rather than a micropile. Soil nailing, nail, those you put on the timber, but you nail it on the soil. It's basically a piece of rod, you put it into the soil, in interval, in the spacing, into a grid, and you cast concrete, a thin layer of concrete over it to form like a skin to protect that soil surface. Ground compaction, you can see from the picture, the compactor. This type of compactor is called sheep foot. Sheep is the animal, sheep. Sheep foot compactor or sheep foot roller that does kneading of the soil. When you knead the dough to make cake, this kneads the soil. Jet grouting uses a machine that has a rod that rotates and spray high pressure water jet and ground at the same time to mix the ground with the soil to form a column of those gray color to improve the soil property. Micropile are small diameter piles. The machine can descend into building to drill holes to create micropiles to strengthen. Many old buildings in Singapore has added micropiles to improve the loading capacity. The famous building, City Hall City Hall, the old building, not the Raffles City. The City Hall in front of the big Padang, the old building, originally only has one basement. But if you visit City Hall now with the art gallery, you will find there is basement 2. Basement 2 was created and it sits on my house. Soil nailing, you see this picture. There are many soil nails that has been installed with mesh linking all of them, and you get spray concrete to create a skin of concrete surface to protect the slope of soil. For basement structure, many a time you have groundwater trying to seep into your basement. Many basement, I don't know whether you visit basement or not, or buildings, because maybe car park, even though you visit the food court in B2, B1, you may not see any water seepage problem, because you are not in those areas that are open to water seepage. Water trying to get into your basement because you have created a void inside the ground, and the groundwater table wants to get into that void. If your basement structure is not waterproof or watertight, you have a lot of water ingress problem. Water coming through will come in contact with your reinforcement bar inside your RC. Water and metal corrosion. Over a long time, the corroded metal will cause structural defect. And the stain from your corrosion, when it's brought into the building through the cracks, will cause staining on the structure. So you want to have watertight basement, you install waterproofing to prevent water from coming into your structure. There are many ways to do waterproofing in the basement. You can use preform waterproof membrane. You can use additive, you mix it in your basement structure concrete to improve the property of your water tightness. Or you can do grout injection if you have leaks that you discover. The injection of grout can be PU or urethane that are non-structural, or you can use structural grout like epoxy. This is what you don't want to have in your basement, where you see water coming through the cracks. You can do grouting if you discover them. When you do construction, you must select the right type of waterproofing system. Waterproofing system, if you ask any supplier, any producer, they will tell you their waterproofing system is the best. Can suit any of your construction. The story is only half true. System can be good, but the installation may not be. Alright? Waterproofing must be a complete and uninterrupted system. You cannot have waterproofing on the wall that doesn't tie with your slab. You must have a complete lab to form a continuous layer of waterproofing system in order for it to work. So you can see this picture that the waterproof membrane, indicated by those dotted lines, must form a continuous system. You must have sufficient overlap between the joints. Please have your mobile phone on the side. We move on to the next part that deals with the foundation. What is foundation? What is the definition of foundation? Foundation is the lowest part, lowest structure in your building that carries the load of your building and transmit it into the ground. That's what the definition of the foundation. Foundation must be designed to be strong enough to carry the load and have the piling system or the foundation system to transmit the load into the ground effectively with safety factor. Foundation must not cause excessive settlement. What is allowable settlement that you think a building can sustain? What's the number? Say a building of 10-story high. What is the settlement that you think you can allow that building to settle? Numbers? What's your view? Zero? What do you think? 5 mm? 20? 30? 100? 20 anymore? July? 10. April? Fine. Anyone else? $25. 25, that would be the rough figure. That is an allowable settlement figure. Anything beyond that, you need to recalculate to make sure that you limit your settlement to that range. Anything less than that means you are in the bonus. You can achieve less settlement than the limit. Foundation in Singapore. Because you are transmitting your load into the soil, you want to know what type of soil is underneath your area or your building. Singapore geological map, in this multicolored map of Singapore, very distinctive 4 types of formation. The one in the middle, the bluish, is called the Bukit Timah Formation. If you understand Singapore geography, you know the center area is called Bukit Timah, the tallest hill of Singapore is called Bukit Timah. So therefore the center part is called the Bukit Timah Formation. Bukit Timah Formation is the granite formation. Underneath there is granite. Towards the east, you see those in green. Those are called old alluvium. Old alluvium are or was rock before, but over time it gets weathered. It gets disintegrated into soil-like material. Still hard, but depending on its degree of weathering, it can become sand. And on the west side, in yellow color, those are called Jurong Formation. Quite easily to remember because west side is Jurong area. Jurong Formation has also rock underneath, but different types of rock. They are sedimentary rock, sandstone, siltstone, mudstone. So 3 distinctive formation: center, east and west. Center, Bukit Timah, granite. East, old alluvium, weathered rock, and west, Jurong Formation, sandstone, siltstone. And in between them, you see those orangey color. Those are called Kallang Formation, soft soil, marine clay. And from the location of these Kallang Formation, you can tell they are waterways, they are rivers, or reclaimed land near sea, or the river mouth. So very distinctive 4 types of formation in Singapore geology. Kallang Formation is what you don't want because they are sediment, soft soil, organic soil, you were to build on those areas, then you need very tough and strong and long foundation because you want to find the competent layer further deep down. And very interestingly, in the downtown of Singapore, on the south side, they are mainly Kallang Formation. Imagine those tall buildings like Raffles City, Guok Hall Tower. The amount of foundation underneath is tremendous. Marina Bay Sands, the MBS, Tower 2, hotel has 3 meter diameter bore power, 89 meters deep. Different formation in more detail, but they can be amalgamated to or generalized to Uktima granite, Uktima formation, Jurong formation, and alluvium together with Kallang formation. You can read them in your notes to understand what are the details inside. Foundation can be generalized into two categories: shallow foundation and deep foundation. Shallow foundation of the name, shallow, not very deep. Since it's shallow, it only carries small load. Small load sitting on good soil. If you have bad soil, you cannot do shallow foundation. Soft soil cannot do shallow foundation. Shallow foundation also has various types. Pad foundation, you see in the picture, pad, P-A-D, means individual footing. The pad can be square, rectangular, circular, depending on what you want to do. You can also do strip footing. Long slab that carries the wall. Pad footing carries the cap column. Or you can do raft foundation. Raft means one big piece of slab cover the entire footprint. Deep foundation used for very heavy load. See, when you have soft soil underneath, you need to extend your pile to greater depth to find a competent layer so that you can sit your foundation on. Different types of pile, how you can classify it with the how the capacity is derived. You can call it friction pile if the capacity is derived from the shaft friction. Shaft is the vertical face of the pipe or the RC pile or bulk pile. It's the surface area of the tube that is coming into contact with soil. The soil interaction, the friction between the pile and the soil is called skin friction. End bearing pile, from the name, end of the pile that bears onto the soil. End bearing sitting on the soil underneath that develop the bearing capacity, and that capacity is called end bearing capacity. So each pile has either one component, which is the skin friction, or end bearing, or combination of both skin friction and end bearing. You can also classify your pile through his method of installation. Displacement pile, one of them, displaces the soil. There's no removal of soil. You do not extract the soil. You merely bang the pile into the soil and you displace the soil through the volume of the pile. Those are called displacement pile. Displacement pile are precast pile, timber pile, bark pile, steel piles. Sheet pile is also one of them, called displacement pile. Or you can do non-displacement pile. Non-displacement means you remove the soil. You do not display the soil, you remove the soil, but you replace it with RC, concrete. This non-displacement power is also called replacement power. Horsepower is one of them. Caisson is another. Micropower is another one. You can have a combination of raft and power, which is called a power raft. Very common in tall building design. When you do a power raft, you have the power to extend your load into the ground to a competent layer. You then combine with the raft to balance up the loading within your building so that you do not have differential setup. With that, we conclude our chapter on foundation underground construction. Question from anyone?